it's no secret at this point. We've obviously been working with it throughout. Every time we've executed a command, every time we've opened up a terminal, we are interacting with the bash shell. Now, we did mention in the early goings that there are different shells out there. There's the T shell, the corn shell, the C shell, half a dozen other ones out there, and they all have their purposes. They all have their dedicated users. We focus on bash because it's the default shell. Every time we've created a user, they are automatically assigned the bash shell. There's still the Bourne shell kind of working behind the scenes. Remember that bash is essentially the derivative of the Bourne shell and the C shell. So we'll talk about basic shell operations. We'll go through the process of writing very simple shell scripts to a little bit more advanced. We're definitely not going to get too crazy with nested loop statements and too many complicated if then else type scenarios. We just need to focus on the basic elements here for the purposes of the exam and for some minor things that you may want to script on your own. Then we'll go ahead into how we can customize the bash shell, just really looking at some of the variables we have at our disposal. And redirecting standard input and output. We've done that a couple of times already in some of our demonstrations, utilizing various control statements within our shell scripts. So we've mentioned scripts in earlier sessions, and there's actually a couple of scripts that run automatically just with the normal installation. For example, the Cron System. The Cron System is a daemon that runs in the background and essentially scans the system to see if it has any tasks that it needs to run in a current minute. There's a script that basically scans all of the cron tables, which is what we use when we're building a cron job, and it's something we're going to take a look at here in a little bit. It's going to scan the system for any active cron tables and answer the question, do I have a job to run in this current minute, yes or no? There's a script for that. There's obviously scripts that are used to collect the logs from various applications and send them to the appropriate log directory, the appropriate log file. So scripts are always working behind the scenes. We're focusing on creating our own here from scratch. So we'll focus on the bash for the purposes of the certification exam, but just kind of keep in mind that there are different shells that are able to take advantage of different types of scripts, but they are an entirely different language. The Bourne shell has a lot of similarities to bash because bash is a derivative of it, as we see here. The bash is essentially the offspring of the corn shell and the C shell, and as well as the Bourne shell, because every shell is essentially a descendant of that Bourne shell. Now, the primary functions of the bash shell is what we've seen already. Prompting for input, waiting for a command, producing some sort of output. Now, when we enter in a command, it's going to do things like verify command syntax and execution of the command itself. We also take advantage of wildcards to substitute a portion or portions of a text string. We can also determine the source of input and redetermine the location of the output. That's all about input and output redirection. So we've used wildcards a couple of times already when we're executing various commands. We've seen them with our regular expressions. We saw them when we were finding files on our system. Just to have a dedicated table that establishes what they are, the asterisk will match 0 or infinite characters. That character can either exist or there can be 10,000 instances of that character. It's basically a 0 to infinity. Question mark represents one single character position. So if I were looking for a file that has 4 letters and I only know the first letter, a better alternative as opposed to a wildcard would be the first character and 3 question marks because I'm looking for 4 specific positions. Then we have the range of characters. So when you enclose a range of characters in square brackets, you essentially have to read that as A or B or C or D, whatever else you have in there. Now, just because it uses alphabetical order here doesn't mean that's necessarily the case. You can say A, Z, W if you wanted to. Not that that would make much sense, but technically that is an option. You can look for numbers, you can look for individual characters themselves. The other thing that we see here is matching a character range. So instead of specifying individual characters in the square brackets, you can say the letters A through E, and that would essentially look for A and B and C and D all the way through the range Once again, you can also use numbers with that. Now, if you're looking for something that is the opposite of your criteria, the exclamation point is kind of one of those built-in characters that does that. So we see a couple examples of here saying, match any character that is not listed, or match any character not within the range. So for that first example, it would show us basically everything from the letter F onwards. In the range of characters, it would show us anything F, G, H, J, K, all the way through the letters of the alphabet. The not is represented by the exclamation point. Now, if you're looking for specific text strings or combination of text strings, you utilize curly brackets as opposed to square brackets. And then if you're looking for a variable, you can use the dollar symbol to represent that information, the value of a variable, if you will. So those are the basic wildcards that we have at our disposal, and these work both within the bash shell as well as shell scripts. So let's go ahead and start creating very basic shell scripts and kind of work our way up towards more complicated ones. Fair warning, I did mention it, we do have to do a very basic hello world script. And we'll talk about modifying the permissions and those sorts of things. So when we take a look at the shell script, and looks like I was on the wrong window there for a second. There we go. Actually, I'm going to do this as a non-administrative user. We'll do this as regular old Luke Skywalker and let him get rocking and rolling. We've done enough work as root, and we'll see. We just want to make sure that we're not throwing it off when it comes to administrative level permissions or those sorts of things. So one recommendation, and I try to include as many best practices as I can, if you think that you're going to be writing a variety of scripts, go ahead and make a dedicated directory for those scripts, because the path variable is what we use every time we run an executable. And we discussed this in the early goings. Every executable that we've ran on the system is located in one of these locations, and more importantly, it's known to the path variable. Otherwise, if I were to take a look at, let's do a listing in, be nice if I could type here, user local bin, for example, and let's just do a grep and find a ping, if you will. It's not in that directory, it's actually in a different directory. User local bin. We are looking for user sbin. Oh, sudo, duh. We can't view those contents. I forgot I wasn't logged in as root. Or not. cd into user local bin. Are we having more issues that we were having yesterday? Do a listing here. Okay, my apologies for that. Typing in the wrong directory. Okay, so I changed into the user bin. The local bin is for my own individual scripts. I jumped ahead of my own demonstration here. I was talking about creating your own directory, not actually looking at the existing executables. So every time we run a command here, it's known to the path variable. Otherwise, I would have to go in and say user bin, and just to pick an example here, if I did zip, that's going to be essentially the equivalent of just typing in the zip command by itself. So we utilize that path variable so that we don't have to use the full path name every time we run a command. The reason that's important to shell scripting is because more than likely, you want to be able to call your script from wherever you are in the system. You don't have to type in the entire path name each and every time you run a very simple command. So one of the things that is recommended is to create a directory underneath your home directory, and you can call it bin, you can call it shell scripts, you can call it my scripts, you can call whatever you want to, but it is a good idea to put all of your shell scripts into a dedicated directory. So very basic, let's go ahead and create our first script, and we'll just simply call it hello.shell. Now, for the record, your shell scripts don't have to end in .sh. They can be whatever you want to. This is another best practice that it's a dead giveaway when you look at the contents of a directory. This is a shell script, this is a text file. It's technically not required, it's just a best practice. So I'm going to go ahead and create this file called hello.shell. And the basic elements of a shell script, what shell is it intended to run, and what are you trying to do? So the first statement that you always want to include is, of course, going to insert mode because you're in a text editor, is what's called the shebang. The shebang is the first line, and it should be included at the top of all of your scripts. It tells your shell, whatever that shell is, that whatever is contained in this script needs to be executed in a bash shell. If I were writing a shell script, say that 10 times fast, I would have to specify bin C shell. If I was writing a corn shell script, I would have to specify bin corn shell. So this is one of those lines of information that you should always memorize. Now, another thing that's technically not required but considered a best practice is to plug in comments. Comments let other people know and also serve as a reminder to what the script does at various points in time. So I'm just going to simply say, this is my first script. Anything that has a hashtag, with the exception of the shebang. The shebang is one of those special things that don't apply to the rules, kind of the I before E type scenario. Anything prefaced with a hashtag is comments or are comments. They're going to be ignored when you go to execute your shell script. So we've got the initial requirements. Now what do I want my script to do? Echo hello world. I know if you've taken any sort of programming class, any sort of scripting class, you're probably thinking, big whoop, I've done this a million times. But I technically have a functioning shell script. I'm just going to say script from here on out so I don't get any more tongue-tied than I already am. Now that the script exists and I'm currently in the directory, let's see what happens. When I type in hello.shell, permission denied. So kind of going back to what we were talking about yesterday, if I do a long listing on this current directory, I tried to execute a shell script, it doesn't know what that is because it doesn't have the executable permission. Now a shortcut way to at least attempt to run this is to type in /hello.shell. That's supposed to work. We should also try hello.shell. You can, as the root user, type in, oh, and I forgot my blank space in there. There's supposed to be a space in between the period and the /. But if you type in shell followed by the name of the script, it temporarily assigns it the executable permission. But since we don't want to do that each and every time, let's go ahead and schmod those permissions. And let's say owner has full permissions, group has read and execute, or I'm sorry, that's read only. We want to do 755 permissions on this one. Read and execute, read and execute. This script doesn't have anything sensitive in it, so I really don't have any qualms about giving the others any sort of executable access to it. It's also located within my home directory, so there's going to be other mechanisms that prevent them from accessing it. So now that I have the appropriate permissions, if I can just type in the name of the script, Bash is going to read the contents of that script and essentially produce whatever that output is going to be. Now, when we take a look at this, I'm going to make a copy of it, hello.shell, and let's just call it hello1.shell, because we're going to borrow some of these elements, and once again, we're going to take it extremely slow and work our way up to more advanced scripts. We just want to make sure we understand the difference between commentary and what goes into a command. So I'm going to open this up in Vim, the copy that we made, and we've got our commentary in here. I'm going to change this to my second script because we practice what we preach. We put in commentary. And let's see what happens if I throw in some random parts of text here. Is the main part of this script, close parentheses. Let's escape. Let's right quit these changes. Let's chmod those permissions again, 755 on hello1.shell. And let's see what happens when we execute it. We get a syntax error. So within your bash script, you have to be aware of your commands, your syntax requirements. If you have an open parentheses, you need to have a close parentheses. But this is a good example of showing you what bash does for us. It interprets the input and produces some sort of output. Now in this case, compare the output to what we see when we run our first script. There are technically two types of output within bash. Standard out, which gets abbreviated as std out, and standard error, stderr. Standard error, the reason that we have the two different streams of output is because sometimes our commands execute successfully and we want them to create a text file, move a file, make a directory, change directories, whatever the case may be. Other times there's an error and we want to be aware of what those errors are. So keep in mind that there are two types of output. Standard out, when everything goes as we expect it to, and then standard error, which lets us know why a particular command wasn't able to complete successfully. So let's go ahead and bring something else into the mix. I'm going to copy this one more time, and let's say hello2.shell, vim hello2.shell. So same thing in here. This should execute exactly as we expect it to, but now we want to bring in some variables to the mix. So I'm going to go into insert mode and add another line in here that says echo, and because I'm picky, we'll say this is my third script. Let's bring in a variable. So if I go hello user, you'll notice that Vim changes the color of that input. I know that dark blue is kind of hard to see on your guys' end, but it changes it to a color, and that's a dead giveaway, and that's why I like to use Vim, because when you're writing scripts, the text highlighting definitely makes it a lot easier to decipher. Oh, I'm defining a variable. Oh, I'm calling a command. Oh, this is going to be some type of output, whatever the case may be. So now that I can call a variable, let's call it again and say hello I am, close quotes here, call in that variable again, user, and we'll be telling you about the current processes, close quotes here. But just to show you that the variables have to be defined, if I were to go hello I am $Dan, and we'll be telling about myself. Let's close this out. Let's keep that hello world in there one more time, and let's say echo the running process list, and then we'll just call the process status command from within the shell script. Let's escape. Let's right quit these changes. Let's clear out our screen. Chmod those. Actually, let me double check. Since we copied the file, it's going to inherit those same permissions, so we don't need to chmod the permissions on hello2. Let's just go hello2.shell and see what happens. So hello L Skywalker, hello I am L Skywalker. It captures my username because the username is a variable that's known to bash. It's already been defined. But if you guys recall, in that third line, hello I am and will be, I specified a variable without defining it. I didn't tell them what the variable Dan equals. So some variables are considered global. They're known to all of your shell sessions. For example, if I were to go Control-Alt F4 here, let's log in as Chewy real quick and do an echo user. That is known for all of our terminal sessions. If I were to go echo path, that is known to all of our terminal sessions. So there's global variables and local variables. Global variables are applicable to all terminal sessions. Local variables are only applicable to that individual shell session.